So, good morning to all. So today we are starting a new lesson. And today we are going to talk about a topic, which topic is generally you all are aware about this one. In this topic, we will study the current and flow of charge. Okay. So when we come for the flow of charge, you always see in your houses, in our classroom also, that when you on the switch, fan will be start moving, light will be lighted up. Okay. So what is the basic thing behind this one? Obviously, you say that current is the reason for these ones. But what is actually present in the current? Okay, so today's topic is current. So current is the basic component of the electricity. Generally electricity as you term, but there is basically behind this is the current. These are both same topics there. So when you on the switch and the fan start moving, so what does actually happening between the switch and the fan? Today we will study. Maybe you are not aware about that, what is actually happening in the wire. So when we switch on the R plug, there is the a direction is directed to the electrons and they start flowing there. Okay, so basically in wires electrons are present there. In non-presence of the current, they are randomly oriented there. But when you on the switch, there will be the electricity you give them. So electricity, when you give them electricity or the current, they are alienated into the one direction and they start flowing, and this flow of the electrons is called as the current. So basically you become familiar about this, that what is the current. Current is basically the flow of the charge. So one thing that you aware or not, but I am generally telling you that electricity or current has direction, because it is the flow of electrons. Means generally term, when you terms it, that flow of electrons. So current is the flow of electrons. So current has direction. But one thing you know in the basic things, that current has direction, but it is not a vector quantity. Anyone aware about this fact? Maybe not. Because it has direction, but still it is the scalar quantity, because it doesn't make any angle with its origin. Okay, so as you saying that when you switch on the plug, the light is flowing in one direction, but there is no angle. If you are taking wire is the any direction, when you switch on, it start flowing. So still it has direction, but it is not a vector quantity. It is only the scalar quantity. So this is the property of the current. That firstly it is the flow of charge. Second is the direction it has. Okay. So another thing, that if you term it is I, so it is the flow of charge. So Q represented by the charge and divided by the time. Means now when you come on the definition of it, so you see in the unit time or in the single second how many charges are flowing. This is the definition of electricity or the current. Okay, so current is basically has its unit is ampere, and ampere is generally coulomb divided by time, means second. So current has unit ampere, which is basically the coulomb divided by second. This is the unit of current. So I equals to Q by T. This is the unit of current. So in our general life, if you imagine the uses of current, so you can term as that if there is no current or there is no electricity, then there will be development is goes to the zero. So in our life, electricity or current is the most important component of our life. We generally using this one. If you are using the mobile phone, so for charging mobile phone you will need the electricity or current, and when you use the laptop there is also need of the electricity or another things where is the basic work is dependent on the electricity. So this is the basic concept of the electricity we generally use in our life. So first work for you, you have to find out at least 5 or the 10 example where electricity is used, and the next one is the electricity which properties it has. This is the your next work to do. And another point that this is the basic concept of the electricity. Now coming on the fact that how we can generate the electricity. So generally electricity is generated by the coals in the thermal power plants, but magnets are also responsible for the generation of current. How? So it's comes under the electric effect of magnet. Okay, so let us take a circuit which has one coil and galvanometer is there, and you took a magnet. Okay, so when you use magnets north pole, which is coming near the coil of the circuit, the galvanometer will start deflecting in the right direction. Okay, and when you drag that magnet farther from the circuit, it will start deflecting the left side. So this deflection of the galvanometers uh, is indicating the electricity. Okay, so this effect is generally known as the Faraday's effect or the magnetic effect of electric effect of the magnet. Okay, thanks.